Welcome everyone. Today we're going to talk about the Pynq on the ZCU104. So let's break this down into what that means. So the ZCU104 is a Xilinx Zinc UltraScale Plus MP-SoC development board. You can get it on Xilinx for about $1,300. They were having it on sale for $800 like, I don't know, half a year ago or something like that. For a cheaper alternative, if you kind of want to follow along and do this your own, for getting about the same piece of hardware, you can get the Ultra 96, which is around $250. That being said, it's not very cheap, but it's a very affordable, capable FPGA at that price point. And yes, you can get cheaper ones. You can get a Zinc or something like that. That's not a Zinc UltraScale Plus, which is older generation, still very capable, but this one is kind of more cutting edge, probably the cheapest cutting edge version you could get today. So let's talk a little bit more about these things. So this is the Zinc UltraScale. I like this board. It has HDMI in and out. You can do video filtering on it. Display port. Other things I like about it is you can put PL DDR. I actually have a PL DDR on mine right here. Was it 16 gigs? I think I have 16 gigs there. So I have DDR. I have the how much DDR is that? 64-bit. We have DDR here for the Zinc, and we have DDR there for the PL. So we can have multiple memory with memory bandwidth, memory ports to different memories, which is very useful when you want to do some applications. You can also throw down a hard drive here if you want to store large video files or something like that. Overall, I think this is a very capable development board. So it's running, it has the Zinc UltraScale 7 EV board. And let's go break down what the EV board is. So the EV board has everything kind of the other ones has, and then it has an integrated video codec. So you can do 4K at 60 frames per second on these devices. So you can do some pretty cool stuff. And looking at this block diagram, we can explain what's actually inside the MP-SoC. So the MP-SoC contains quad ARM A53 processors, has dual R5 real-time processors. You got the memory. You have a graphics unit. I've never really used that, but it can be very useful. Some security stuff and some interfaces on the processor side. Then you have the programmable logic, otherwise known as the FPGA. Go ahead and move that. We have block RAN, alt-RAN, DSPs, video codec. So this is your FPGA that you can play around and reconfigure, and it has a pretty cool relationship between the processor and the fabric. So the cheaper option here is running 3EG, which if we go over here and look at the product table, so we want to compare the 7EV. Why is this? So we want to compare the 7EP, is 504K logic cells, and versus what the 3EG. So I mean, it's drastic reduction in your FPGA resources, but you still get the quad core processor and everything. So it's still a very capable FPGA. And that's the Ultra 96. Comes in this really nice form factor. Has a lot of fun support. So those are the two boards. I just want to give this other option in case anyone wants to follow along or be able to do this on a cool multi-processor board. So we're going to talk about Pynq. So Pynq is kind of a Xilinx's let's just go to the website. That'd probably be the best way to describe it. Read through their little thing. What is it? How did they word it? Like Pynq Python productivity, and they use a Python wrapper with a Linux operating system around your hardware to rapidly test and develop hardware. I've used it. I really enjoyed it. I don't really see many downsides to it. Yes, you can do a lot of this stuff bare metal or with your own implementation, but this is just implementation, so it's easy to rapidly get going. I've been able to test a lot of interfaces really quickly with this, and having a Linux operating system be able to test it as well. So I've enjoyed it a lot. And then they have these really cool Jupyter books where you can interact with hardware. We'll show a quick demo of that later. So let's talk about how we get Pynq on our FPGAs. So they have these downloadable Pynq images, and you just put it on an SD card, you pop it into the device, and you can run it. I don't know what these boards are. I'm kind of curious what these boards are. Prototyping board. Is there a price for it? I just see that. And another prototyping board. Don't really see a price listed. Someone can go hunt that down. But yeah, so we have the ZCU104. We can get one on it. We have the RF sock one is pretty cool, I gotta say. We have this one as well, the Ultra 96 V2, where you can get that working, and you just download the SD card image by clicking these links. Tell you how to get started and whatnot. So we get the image, and you can see, where is it? Right here we have an SD card. But for every FPGA, there's these mode pins right here, and you want to make sure you configure your mode pins for the SD card. So depending on the development board you have or whatnot, you need to go look at these mode pins, and you need to make sure your device is set up in the SD card mode so you can boot up into Python. And then once you get the image, there's multiple ways you can put this onto an SD card. This program right here, Elena Etcher, is probably my favorite Windows program for putting an image on an SD card. It's simple, it's quick, and it's very effective. That's just one thing to use. And so then we can, using this etcher, and then we can kind of look at the Pynq demo. Want to look at the Pynq demo. Oh, we also want to talk about documentation. There's this documentation. Okay, so there's great documentation here where you can go and look at it, and it tells you how to use the notebooks, their Python environments, the different overlays they have. We can go to ZCU104. They have a bunch of cool stuff. I can show you this in a moment. How you can create your own overlays and how you can integrate it and be able to use their awesome interface. Building an SD card. Yeah, so pretty simple stuff. They have a repository. And you can look how they have, this is where they have the hardware documentation. This is kind of where the software is, and that's how you build the Linux image. But it's easy just to get the release and kind of work from the release. And we can show you what the ZCU104 image looks here. You'll notice there's not Ultra 96 here, but the Ultra 96 is on a separate repository. So yeah. So once you get it set up, like they have getting started right here. Boom. We're using Ethernet. Sometimes I avoid the UART. If you have Xilinx running, it can upset the ZCU104. Connect to a computer. We have the Ethernet connecting to a computer right here. We're using just a local IP, so I set up a static IP, and we can go to the Jupyter screen, and we can access files. You can also access the terminal. Anything special here? Nothing terribly special. You can read through it. So here we have kind of the basic Jupyter page where we can run some fun stuff. So I guess the demo I was going to show you here is this register map intro, which is how from the Python code you can access the memory map. And you can also kind of write your own stuff later on, but they have kind of this nice interface. So the first thing you do, so let's see, watch the done light right here. It's, this big one right here. So we're going to run this first line again. How long it takes to run. Oh, must have done it, not changed it because it already was loaded in. Smart program, so it didn't reload it. We set up these things. We can check this out. Read the buttons. The buttons are 0. So let's hold down 2 buttons. Rerun this. Now it's 12. that being 8 and 4. So probably like 1, 2, 4, 8 or something like that. And they have some tools for getting the information. We can also get the LEDs. And let's change some values, right? Let's make that 0, that 1. You can see now we have one LED right there. Change that back to 8, change that to 6. And now we have the other LEDs on. So let's make a counter real quick. What we're going to do here is we're going to insert a cell below, and we're going to import time, I believe. And let's do a for loop I in range 100. So we want to say time.sleep 1, and then we want to say equals I mod 16. There we go. We have now, how well do you guys see it? You can kind of see it. We now have counting LEDs right here. So it's super easy to just like throw down some Python to be interactive hardware. And yes, but this is just your buttons and your LEDs, and there's a lot more hardware on here, and you want to know what you can actually work on and what you can do. So they have a lot of examples. You can have a bunch of Pmod devices you can attach, and they have software for those. They have video. Video is really cool. We have you can do face detection and Sobel filtering with webcam and with the HDMI ports. And they have really cool things and a lot of well-built software. And you can do it. I don't have the HDMIs hooked up right now. Maybe another time we can go through and do this. So it's relatively easy. The cool thing about this is this took me I probably spent maybe 30 minutes before streaming to get this set up. And it's easy to download the Pynq software, to get the Pynq image, to put it on an SD card, to boot up, and to immediately be able to play with the FPGA. And they provide these base overlays. That's what they call it. Overlay is the bit stream that they can put on and off. They call these base overlays pretty comprehensive, and you can do a lot to it. I don't think we have time for. It might be a lot of work to go in and try to do ones because I'm currently waiting on this one to build. Right now, can I? So, but we can walk through this design real quick, which is the this is our base overlay, and we can walk through what's happening here. I wish I had this. I wish I built this earlier. We could have worked on getting the other designs up and running. What is needed to get the SD cards up and going, but maybe we can work on that another time. We might have to cut the stream short. So we have the Pynq running on the Zynq UltraScale Plus device. And let's start, let's look at this block diagram that kind of defines the hardware. So we're going to start with the Zynq UltraScale. Is there a way I can just pop this out, right? And make this the full screen. So we're going to start with the Zynq UltraScale Plus. This is your processor. It has a bunch of configurations. If I wasn't building, I could open up and look at the configuration. And it currently only has one bus, and this is the LPD bus, which means the low power domain bus. So this is the bus on low power domain, and it's currently going to this giant switch, which has one master and like 19 slaves. Not sure how that does in utilization. It can be nasty. But we have a lot of slaves, and maybe we can go through and work through these. But the CPU in there is. We won't be able to go through that. So, processor by where to start. We go to the switch. We have the different interfaces, and let's walk through what we kind of have going here. So these are some simple GPIOs for the HDMI, and it looks like a reset for one of the chips on the card. We have a AXI I2C bus, so this is probably a specific bus on the board that connects to maybe some power regulators or some other devices on the board. I don't see any other I2C device or connection, obviously open or something. Okay. Then we have the LEDs GPIO. We can talk about these Pmods later, but these are the multi-purpose Pmods that we have over here. He only has 2 Pmods, so I wonder if they're only... Well, this Pmod says I2C, so maybe this is the I2C Pmod. We have Pmod 0 and Pmod 1 right there. My hand doesn't get. Then we have interrupt controller, which has 8 interrupts. Go to various systems. I don't have to worry too much about. And then we have GPIO switches, which are probably these 4 switches, like right here. And then the 4 buttons that we saw earlier. Yeah, these are some basic devices, and they simple purposes. So if we go check out what the Pmods are doing, so let's go look at where the Pmods are connected to. So the Pmods are connected to these 2 hierarchical boxes. So there's multiple blocks in here we can't look at right now because I'm doing synthesis. I guess we could pause synthesis since it's not being completed. So it's not gonna be happy with me when I break the script. But let's go ahead and cancel this. I really want to deep dive in here. I'll just have to close and run this later. On place design, which was pretty far, but oh well. So we'll just reset run. Okay, so that's fine. It'll start back there later. So let's break down. Let's go. Yeah, Pmod 0. So inside of Pmod 0, break this out again. So Pmod 0, we have a microblaze here, and this microblaze has an AXI bus that's connected to a switch that has a bunch of different devices, right? A ton of devices. And basically what they have is they have a SPI, an I2C, a GPIO, and then a massive switch that allows you to change which device is connected to the Pmod. So that you can have the microblaze running some kind of embedded code that interacts with this device. And yeah, it can send out interrupt to the main processor as well. So it's kind of a cool little system to kind of independently have a single processor operate your Pmod device. So you to have it dedicated to its operation. So that's all basic interfaces, and still not anything super impressive. So the most impressive part probably of these devices, of these Pynqs, is this video. If you ever want to do like rapid video development, the Pynq is a good one. The ZCU104 may be a little bit rough because you need a license for their HDMI cores. Oh yeah, it may not let me build this at all. It may get angry as soon as I try to do these cores. So I don't know. Maybe it won't build at all. I may have to remove the video. If you work on like other devices that don't have this crazy HDMI transmitter core, then it shouldn't be an issue. So let's follow this video pipeline, right? So we have HDMI out, PHY, an HDMI in, and a video DMA. So okay, let's look at the PHY real quick. So the PHY is just what's generating the I guess outputs and inputs of the video from the raw connections, and that's just giving kind of the raw data. And then here we kind of take that, let's see, take the raw data from the output give it to this, and then it sends it over the transceivers right here. Okay, so let's see. So here's the input transceivers. So these input transceivers come in here. They go through into the PHY. The PHY delivers the data with the status there. And that goes down into this HDMI import. The HDMI import, we have the front end, which is HDMI receiver. It has a video out. That video out is quite a bit data-wise. Wow, interesting. And they have a pixel reorder. I am not sure what. Let me look at this pixel reorder. Exactly sure. Oh, here we go. This is where it's doing the reordering right there. Then it has a register, convert color with pixel packet from memory. And once we pixel packet, we send it to the video DMA, which stores it in the DDR. When it's stored in the DDR, then we can have the processor operate on these frames. Once we want to bring the frames from DDR into the output, we just have this stream over here, take it to the output. We unpack the data from the DDR, we do whatever color conversion we want, and get the data ready for the front end, which converts it into HDMI data and sends it to the PHY. And then the PHY sends it out here. And you can do some really cool things. You can stick in a, what I like to do is somewhere like right here where it's operating on the data, figure out why it's doing the 48 data. If it's doing 48 divided by 3, it's 16 bits per, that'd be 42. I don't know, that'd be right? Yeah, so it'd be 16 bits per color. That seems pretty dramatic. Oh no, you're doing 2 pixels at a time, right? Doing 24 pixels. This allows you to do 4K. This whole video pipeline supports 4K. Oh yeah, so I'm not sure when your message came through. I just saw it. Look at the chat. This is the default overlay for the ZCU104. This is what comes from the Pynq repository. And with a video pipeline system that supports 4K. They do have an issue though that this like the video PHY controller and whatnot may be licensed. I have to build and see if we can build it properly. But yeah. And so yeah, if you wanted to do where would I put it? Usually on the input right here. So right here in the raw data where the stream 48, what you can have some fun and stick in your own hardware video filter. That's what I did for my masters right here, and kind of where this connection is right here. And you can operate on the raw video data to do whatever type of filtering you want to do in hardware. Super fast, super awesome. Okay, so I'm not sure there's much more we can do at this point. I was hoping to be able to build some examples. Rebuild the design it was doing. But yeah, are there any questions? And I'll pay attention to the chat this time so we can see what questions are happening. I hope to maybe tomorrow we can have some time. I can generate a simple overlay and we can port it in and maybe just do like an overlay with just the LEDs and the fun little adder, and we can show you how to do direct memory access with mmap in Python. So we did the demo, custom hardware. We want to do this later. I think that's all that the stream is going to have now. This is just kind of a simple introduction to Python. Getting it running on this device was a lot quicker and easier than I than I planned. Made this a little bit slower. But yeah, so I guess we'll post this to YouTube later, and everyone who's slightly interested can take a quick walkthrough and view of getting this all ready to go. Anything else? If you have any issues getting a Pynq set up on a board, if you want to try to get it set up on one of these other boards like the ZU2 or the ZU1, or ZU2 now. Yeah, so the Z1. These are a little bit cheaper, but this is only $200. Where the ultra scale, like you throw in here the stuff, it's $235. I would almost buy the ultra 96 at that point. Wow, the Pynq Z2 is this no longer being sold? Okay, how much is this one going for? 150. So this one's a little bit cheaper. Kind of provides the same options, HDMI in and out and whatnot. So yeah, ranging from Pynq devices, ranging from 150 to the amazing expensive RF sock where if you want to do any radio stuff, with Pynq provides some really cool platform for this. But this is 9,000. I do not have one of these laying around. If I did, that'd be some really interesting stuff. But yeah, thanks for watching. Sorry, we're short today. Maybe we'll have time to go longer tomorrow, depending upon how Vivado wants to build my design. Bye.